Let's go back in time when Second World War began. Hitler imposed an embargo on the export of gold. When the German troops led by Hitler invaded Denmark, two Nobel laureates feared that their Nobel Prizes made of 23-karat gold metal would be confiscated. They sent their medals to Niels Bohr Institute. One of the scientists in the institute scratched his head to find a way to save the medals. Since gold is adamant, it does not easily react with any reagent. But the guy was very intelligent. He prepared a mixture that dissolved gold in it. Let us find out what this magical reagent was. Gold, as we know, is a metal. To know what the mixture is, we need to study a bit more about metals and their reactions with different acids. There exist more than 80 metals. If you look at the periodic table, all these are metals. It is difficult to study about each metal, so let us take a few of them. Shall we take the metals from the first group? Try recollecting how sodium and potassium react vigorously with water. And this guy cesium, when placed in water, goes boom! It bursts out very vigorously. So imagine how vigorous the reaction can be with acids. Don't try to mess with these metals. How about the other metals in the periodic table? Let's pick some sober metals like magnesium, aluminium, zinc, copper, silver, and gold. We are going to start with hydrochloric acid and find how it reacts with different metals. Let's try with the dilute one. First comes magnesium. Ooh, we see some fumes coming out of the test tube. This guy reacts very fast with dilute hydrochloric acid. Next, aluminium. Bingo! We see fumes again. Aluminium also reacts with dilute hydrochloric acid. Next, when we take up zinc, we find that it reacts as well. That explains why our mums do not keep our sour food in vessels made of these metals. Sour food, as we know, contains acids, and acids react with metals. Now, let's try reacting dilute hydrochloric acid with copper, silver, and gold. Oops, no fumes here. These metals don't react with dilute hydrochloric acid. As dilute hydrochloric acid could not affect copper, silver, and gold, let's try reacting concentrated hydrochloric acid with the metals. Alas, no change here too. Copper, silver, and gold do not react with hydrochloric acid, be it dilute or concentrated. Exactly this point was exploited by gold smugglers to smuggle gold from the country, as gold cannot be affected by hydrochloric acid present in our stomach. However, you cannot pass undetected, as metals inside the body can be detected by metal detectors installed at the airports. Oh yes, custom guys are smarter than smugglers. As magnesium, aluminium, and zinc react with dilute hydrochloric acid, it is imminent that they will react with concentrated hydrochloric acid as well. But the rate at which they react varies from metal to metal. What we see is that the fume coming out of the reaction mixture containing magnesium is stronger than fume in other cases. The amount of fume is a little less for aluminium and decreases further for zinc. Magnesium, thus, is more reactive than aluminium, which in turn is more reactive than zinc. Metals react with acids to produce salt and hydrogen gas. Magnesium reacts with dilute hydrochloric acid to form magnesium chloride and hydrogen gas, and aluminium forms aluminium chloride and hydrogen gas on reaction. Similarly, the other metals from metal chlorides and hydrogen. But how do we say that hydrogen is liberated? Let's take a lighted matchstick near the mouth of all the test tubes after reacting the metals with dilute hydrochloric acid. What do we hear? This pop sound comes from the burning of hydrogen with oxygen in the flame to form vapor. No matter how hard we tried, we could not dissolve the unwavering metals like copper, silver and gold in hydrochloric acid. So let's move to some other acid now. Say hello to sulfuric acid, the king of chemicals. When we reacted all the metals with dilute sulfuric acid, we saw that our big players magnesium, aluminium and zinc reacted easily. They reacted to form corresponding metal sulfates and hydrogen gas. Since copper, silver and gold were still unmoved, we bring a bigger boy, concentrated sulfuric acid. We tried reacting concentrated sulfuric acid with copper and silver. What do we have here? The king of chemicals conquers copper and silver. But how is that so? All along, they did not play well with anyone. Concentrated sulfuric acid acts as a strong oxidizing agent. In this, corresponding metal sulfates and a gas are released. To test the gas that is released, let's bring a lighted matchstick near the mouth of the test tube. No pop sound this time. Surprising? The gas produced is not hydrogen here. So what is it? We can pass this gas evolved through the potassium dichromate solution. How bright this potassium dichromate solution looks. Oh, we see some changes in color. The orange color is changing to green. Fantastic! This confirms the evolution of sulfur dioxide. We can thus say that concentrated sulfuric acid oxidizes the hydrogen formed to water and gets reduced to sulfur dioxide. The reaction of copper and silver with concentrated sulfuric acid can be represented as: copper reacts with sulfuric acid to give copper sulfate, sulfur dioxide and water. Silver reacts with sulfuric acid to give silver sulfate, water and sulfur dioxide. Now, let's try our safest gold with the king of chemicals. Oh, no effect yet. Gold must be telling sulfuric acid that if you are the king of chemicals, I am the king of metals. You must be thinking gold never reacts, no matter how strong the guy attacking may be. Or for that matter, how did the brainy scientist save the gold medals from the German conquerors? Let us bring another strong guy into the picture. Nitric acid. Let us react dilute nitric acid with all the metals one by one. Magnesium, aluminium and zinc react with dilute nitric acid to form corresponding metal nitrates and hydrogen gas. Yet once again, no effect on copper, silver and gold. Let's not be disappointed and keep trying. What if we take concentrated nitric acid and try reacting it with copper, silver and gold? Copper and silver react with concentrated nitric acid in a way similar to how they reacted with concentrated sulfuric acid, but with some more fumes and colors. Concentrated nitric acid is also a strong oxidizing agent. The hydrogen produced in this reaction is oxidized to water, and nitric acid itself reduces to nitric oxide or nitrogen dioxide. The reactions of copper can be represented as: copper reacts with nitric acid to give copper nitrate, nitric oxide and water, or copper can react with nitric acid to give copper nitrate, nitrogen dioxide and water. Silver reacts in the same way. The reactions can be represented as: silver reacts with nitric acid to give silver nitrate, nitric oxide and water. Silver can also react with nitric acid to give silver nitrate, nitrogen dioxide and water. But gold is still playing a safe game here. Concentrated nitric acid could not affect gold. Let's act a little smart now with our noble metal gold. What if we tried dissolving gold in a highly corrosive yellowish-orange fuming liquid which I prepared right before this lecture? Oh, what do we have at last? It's dissolving! Phew, finally! This fuming liquid is Aqua Regia, the mixture of concentrated nitric acid and concentrated hydrochloric acid, taken in the ratio of 1:3. Yes, you're thinking right. The scientists dissolved the gold in a jar containing Aqua Regia and kept the jar on a shelf. The Germans came but never realized that the jar contained gold. Once the war ended, the scientists went back to find the jar on the same shelf. The Nobel Committee then recast the medals for the Nobel laureates. Finally, we can conclude that metals react with acids to form salt and hydrogen gas. Some metals like copper and silver react with concentrated sulfuric acid and nitric acid to release sulfur dioxide and nitrogen oxide respectively. Gold, however, does not react with hydrochloric, sulfuric or nitric acids, but with a mixture of nitric acid and hydrochloric acid in the ratio of 1:3. This mixture of nitric acid and hydrochloric acid is Aqua Regia.